Okay, let's start with functions. Now, functions is the chapter which I think is it's conceptually and algebraically also pretty straightforward, but because there's a lot of algebra involved, in my opinion, a lot of the students miss the big picture of functions or why do we really need it, right? So, functions that is explanation maybe a bigger chapter, so this video will probably not cover all of it. I will probably talk about what functions are, why do we need them, etc. Like just the intro, right? The different types of functions. I'll talk about the concept of domain and range, and also inverses, right? This is probably what will be it for this video, right? And what would be left would be quadratics, and that's a big part because in your exams, a lot of the questions are from quadratics. Secondly, modified functions, right? These are also fairly important. And what's the most important, in my opinion, is are the composite functions, right? And understanding how composite functions work is pretty important. Right, so let's kick off with what functions are. So if you're a computer science student, you probably know what functions are, right? But even for the average layman, functions is something along the idea that you do something, right? You give some input, right? The function does something to it, and it spits out an output, right? And this is basically what it is. The function takes an input, it does something to it, and it gives out an output. So when we write y equals 2x plus 3, right? And for the time being, let me just tell you that x is an element of all real values. Right? This is what's called the domain. I will talk about this later, but for the time being, what I'm basically saying is that this value x, it can be anywhere on the number line from 0 to all the way you can go to the right and all the way you can go to the left. It can be any number, right? X can be any number. It can be -1, it can be negative half, it can be 1, it can be pi. Right. So x is a variable over here, right? We are defining the output y, what the y value is the output, right? We are inputting some value x, and what we are doing to that value, will multiplying that by 2, and whatever answer that gives us, we are adding 3 to it, and whatever answer we get is the value of y. That's the output. So here the output is y, the input is x, and this whole, let me change the color, and this whole is our function, right? Since we are defining y in terms of x, y is a function of x, right? And f of x is basically 2x plus 3. What we're saying is, no, whatever x is, what you do is you take that input, you multiply it by 2, and then you add 3 to it. So for example, if I say what is f of 1, it would be just replace x with 1, right? This would be 2 plus 3, 5. If I say what's f of 2, it would be 2 times 2 plus 3, which is 7, right? So when you draw your graphs, let me just make a rough drawing of 2x plus 3. 2x plus 3 looks something like this, right? So on the x-axis, these are all your inputs, right? These are all your inputs. And this y-axis, these are all your outputs. So y is the output, x is the input, right? And what this basically means is that when x is of this value, right? When x is of this value, the output is this certain value of x. So for example, when x is 1, the output the function will give would be 5. When x is 2, the output the function gives will be 7. And this line you could call, this is like the function. It is giving, if it is giving you the value for every x, right? What would be the value of y when you input x, such like this? What will be the value when you input it like this? Right? And this is the big idea about functions. This is it, that you give some input, it does something to it, and you get the output. And we're defining y in terms of x. We're defining y in terms of x because this is the input and y would be the output. Right. So these are functions. Right. Now let us look at the different types of functions there are. Let me draw a graph. Okay. Now, I just gave you the example of 2x plus 3. It is called a linear function. And in a linear function, is when it's a line, let me draw a list of inputs over here, right? The inputs go through the function, and these are the outputs, right? So when I input 1 into it, it gives me the value 5. When I input 2 into it, it gives me the value 7. When I input 3 into it, it gives me the value 9. Right? So graphically, what this means that at this value, x is 1, y is 5. And such a function which whose output has only one unique input to it, we call this function a one-to-one function. And what this means is that basically, if you have this output 9, 9 can only be achieved when you input 3 into it and no other value. There won't be any other value. Let me draw the arrow going towards there. There won't be any other value x, which if you input into the function, it will also give you 9, right? So basically, it is a one-to-one function if there's only one arrow pointing to the output, right? One went to 5, two went to 7, three went to 9, and there's only one arrow that is pointing towards 5, 7, and 9, right? Let me give you another example. Let me take a classic quadratic, right? We'll cover quadratic in detail later, but for the time being, this is y equals x square, right? Now let's take our inputs. It will go through the function x square. Let me take out some outputs. Right. So when I input 1 into it, what output does it give me? So y equals 1 squared, it gives me 1. It gives me 1. When I input negative 1, what does it give me? It gives me 1 again. So negative 1 and 1 both go to the same output 1. To give you another example, if I input 2 and minus 2, both of them would go to 4. Right. So here you see that to only one single output, there are two arrows pointing to it. Or in a more meaningful way, for one input, for one output, there are two inputs. Right. You can input two separate values and it would give you the same output. Right. And when you have such a condition, we call this a two-to-one function. And you can probably draw the relation that as the number of arrows over here would increase, this would increase likewise. So just to convince yourself that you've got it down, just to see if you've got it down, convince yourself which function would this be. I'll just tell you that this is a 3-to-1 function, but just question yourself why that is the case, right? So whatever I've done over here and here, it would be summarized with the horizontal line test. Right? Now what the horizontal line test is that if you drop a horizontal line in the graph, right? It is a function which basically you want it to intersect at the maximum points it can. So let me take this graph over here. If I drop a horizontal line over here, it intersects at 1, 2, 3 points. So this is a 3-to-1 function. If I drop a horizontal line over here, this will be a 2-to-1 function. If I drop a horizontal line here, it will be a 1-to-1 function, right? And just so that you know the intuition behind it, for example, if this is the value of y1, y will be 1 when x is both negative 1 and 1, right? If I take the value of y as 4, when y is 4, the x value can either be negative 2 or it can also be 2, right? And the last type of graph, which is not really a function, is what maybe some students get confused. And so, for example, if I gave you, let's take y squared is equal x, right? So y is root x and negative root x. And the graph looks something like this. Let me draw a bit neater graph. Looks something like this, like this. Okay, so let's draw our basic structure again of inputs and outputs. These are the inputs, these are the outputs, right? So when the output is, let's take, when x is 4, y is either 2 or negative 2, right? Because it's either positive root x or negative root x. When it's 9, it's either 3 or negative 3. And the graphical meaning of this is that when x is 4, these are the two values of y, negative 2 and 2. When x is 9, these are the two values of y, negative 3 and 3. So for the same input, let me change color. For the same input, you're getting two different outputs, and this is why this is not considered a function at all. This is not a function, right? And maybe to draw some analogy that might help you remember, think of the function as some vending machine, right? This is our vending machine. Let's call it a function, right? And there are keys over here: 1, 2, 3, 4, 5, 6, 7, 8, 9, right? All the way till 9. And you put your money in here. So the vending machine is such that, for example, when I press 1, it gives me cola, let's say. And when I press 4, it gives me, let's say, it gives me Lays, right? When I'm pressing keys, I'm basically giving the function an input, and it is giving me out a product, an output. Right. So the function is such a vending machine that if I press two different keys over here and it gives me the same output, it is completely fine because I will still have to pay every time. I will still have to insert a coin over here every time I press a key. So for example, if pressing 1 and then inserting a coin gave me cola, and pressing a 7 and inserting a coin also gave me cola, it is completely fine because I still have to insert a coin. So two different keys can give me the same product and it will be completely fine. What would not be fine if, let's say, I press 2 and it gave me two different products at the same time. So for example, if I pressed 5 over here and it gave me Sprite and it also gave me Cheetos, right? This is not acceptable because you're inserting only one coin and you're getting two different products for the same price. So this was just an analogy that would maybe help you remember that this is not a function, right? And to test whether something is a function or not, like we did for the category, for the category we did the horizontal line test. To test whether a graph is a function or not, we do the vertical line test. So for example, if I gave you something like this, right? I will drop a vertical line such that it intersects the curve at most points, right? And here we see that oops, my alarm went off. We see that it intersects at 3 points, hence it is not a function. For it to be a function, it must only intersect at 1 point because one input, one value of x should only give one output for it to be a function. So for example, if I drop a vertical line here, it intersects at 2 points, hence it is not a function, right? Anywhere I drop a vertical line here, it will always have only one intersection. Same goes for this, only one intersection. Same goes for this, only a one intersection, right? So this is how you check whether it is a function or not. Vertical line test is to check whether it is a function or not, and horizontal line test to check what type of a function it is.